Thank you. First off, I'm very excited to be here at this leadership forum to talk about 5G. 5G is probably going to be one of the most exciting technologies that we'll be talking about for at least for this decade and beyond, because it represents a point of inflection in typically how we view technology in terms of the history of mankind so far. And it's not really an exaggeration as I kind of get through some of the use cases. So first off, before I jump right in, I'm very proud to be working for Verizon, who is a global leader in 5G. And and it's my honor to present the topic of 5G in this forum. What we will be covering in this session are 5G and the evolution, how the various exciting opportunities get created along the way for a variety of industries globally. And of course, any new technology comes with its challenges. And what are those challenges and what are being done about those? And of course, what next? So this is going to be the theme. And what we are definitely not going to cover are anything specific to what my company is doing, because I'm here as a technology evangelist, and how and basically explain how 5G is going to create this exciting opportunities to advance digital transformation, as well as bring together the complementary emerging technologies like ML, AI, AR, VR, all these wonderful acronyms we hear. How is it going to really bring them to life and unleash these opportunities of future that we arguably haven't even thought of, honestly? So without further ado, let me jump right in. Before that, a quick technical aspect. We got to understand the evolution from two aspects, right? We need to we all know that when we went from 1G all the way through 2G, 3G, 4G, and 5G, and I have a few slides covering some of that later. What we see are drastically more and more bandwidths. For example, way back when you were not able to, stream a video on YouTube even a decade ago, or maybe a decade and a half ago, as well as we can do it now. So if you ask what is 5G, people say, oh, it's faster. Uh, and they say the data rates are higher. And what about propagation? What about penetration? What about the availability of spectrum? And these are the critical aspects that we need to understand uh, today before we jump right in. I'm not going to go spend a lot of time, but we need to understand that as we move from the longer wavelength or lower frequencies, lower speeds, to a higher frequency, which is what 5G represents from left to right, you can see that the propagation, which was much broader and wider with the lower bands, lower generation of 4G and below, you lose that when you go to high frequency, because the faster you go, the faster it attenuates. So the propagation is not far, which I'm sure a lot of you have heard. And the penetration also breaks down. Why concrete walls, windows, and high efficiency windows, etc., they represent the signal bouncing multiple times before it enters because of the speeds. And data rates, as you can see, are much, much higher, and the availability of spectrum is much higher. And in fact, because of the broader band available, the at a higher bandwidth, at a higher frequency, because it's not used. At a lower frequency range, it's highly overused across the globe. And that's the reason we're able to promise high throughputs and high speeds. And it comes to the cost of propagation. So moving on, what is 5G? What's the evolution look like? As you can see here, roughly every decade, we've had a new generation of the 5G from an evolution perspective. So in the 80s, we had analog voice from a cellular connection perspective. The cell phones used to look like a brick size or even bigger, and they used to emit a lot of heat, so you can't really hold them and talk all the time. You had to literally set it down and talk with a huge antenna. It looked really odd if you compare it to today's cells, but back then it was really useful for people who needed to communicate on the go. Emergency services, lawyers and doctors and so on and so forth, right? they all, some of those folks absolutely started using this analog voice, and the quality was poor, as you can imagine, because it's pretty much circuit based voice. It's TDM circuits of the old technology that we have in communications, to where, as you can see, when we go to 4G, we get to packet voice. So 1G, and then the next generation 2G, roughly a decade later, we basically say, hey, it's not just voice. What if we want to send some short messages? And that's when the text messaging of the SMS, the short message service, sprung into action. And very simple, I won't call it email, but simple long messages as well started coming in, but the speed was very, very low. And then when we went up to 3G, this is where we saw a significant shift. And the excitement really extended beyond people who really just need a phone to communicate to actually a lot more applications. It went into, because we are all excited, we want to be connected. And the whole idea of always connected started with 3G, right? What did that do? It allowed us to connect at higher speeds and higher bandwidths. So you can get emails communicating with each other. You can look at videos on YouTube. Of course, there was a lot of spinning going on, buffering going on for obvious reasons, because the speed was not as high as 4G and beyond. So as a result, there were some initial apps which did not require streaming, where you could download all of it and then play it, and those kind of things worked outstandingly well. So, and the whole concept of a smartphone came to life with 3G. And 3G literally enabled a smartphone. And in fact, Apple gets the credit for that, for really kickstarting the smartphone revolution, which really required 3G. So they're complementary in nature. So I'm trying to evolve a theme here where we have to understand these generations of technology are telecommunications related, right? It's about speed and throughput, all the way from 1G to 4G. But from 4G to 5G, it's a quantum leap, it's a quantum shift in many more attributes that spring to life. And that's the reason this is, I call this, a lot of leaders of 5G call this, and a point of inflection where technology is going to transform the way we live, we play, we eat, we learn, we work, and we exist in the world, and we communicate, of course. So uh, what happened from 3G to 4G is the speed and throughput has increased dramatically, and we started seeing a lot of streaming. Netflix wouldn't have been in existence without 4G, right? So Netflix, YouTube streaming, and all the other streaming services that you use today, including Disney's and Hulu's and HBO's and whatnot, wouldn't have come to life without 4G. And the beginnings of IoT, Internet of Things, which are literally all these last mile devices like the wearables that I'm wearing, like a Fitbit, your Apple Watches, ranging from those all the way to electric meters, where they automatically read your meter and send out a reading periodically to the department. So it basically avoids somebody making a milk run home to home, capturing those readings on a regular basis. And it's also environmentally friendly because people drive. That's a lot of pollution across the globe, right? So this, when we basically bring in 4G with simple IoT, we were able to bring all these last mile devices. But there's a limitation. You can have 100 to maybe at the most. Again, there's limitations of physics, how many devices you can have. You could not possibly support more than 1,000 devices in a square kilometer. That was the limitation of 4G. But come 5G, this is dramatically changing everything. And we'll learn a few of those specifics in the subsequent slides. But what does it unleash? Massive IoT with up to 1 million devices in a square kilometer. That's mind-boggling. And that's exactly what exists today. In our home, when the pandemic started, both our kids and the schools, were remote. Both our kids were complaining that they were not able to watch the videos that the teachers were showing. And we were like, wait a minute, we have 1 gig Ethernet, gigabit Ethernet at home, and what's the problem? And we realized that we had 16 devices that were connected on Wi-Fi. So we literally had to shut out a lot of devices that don't need internet, especially when the kids had to learn and we had to both work, me and my wife, from home. These are the challenges today that they're clearly visible. 5G is going to significantly change that. And 18 devices in one home is just mind boggling. iPads and phones and Fitbits and whatnot, right? So, long story short, multiple devices in a small footprint, and we transition to packet voice, which is much more higher quality from a QoS perspective, because voice and video are two services that we all know. We can tell when there's buffering because you can't hear the voice, you hear static, you hear breaking of packets, right? You hear that the frames are breaking up and so on and so forth. Same thing with video, right? You see the spinning wheel when it starts buffering. And so, long story short, where I'm going with this is when you move to packet voice, the QoS significantly improves quality, where it's a lot more smoother, and the bit rates and all the checks and balances are of much higher quality. So now, yeah, that is carried forward at a much higher quality to 5G, really. And some of the aspects of IMS core will continue to support 5G voice. And this is where I have a slide later that shows that 5G is not changing everything from an infrastructure perspective. It is absolutely changing a few things, like fiber densification, because we need a lot more 5G cells as it cannot penetrate farther, versus a big tower that can arguably support a 10 square kilometer radius, and some of the larger towers can support 20 square kilometer radius and even beyond. So that's pretty huge versus 5G that cannot really go past a few thousand feet, really, at the highest speeds. So, long story short, where I'm trying to go here is it's a very high speed play. You get the 4G infrastructure that combines with the 5G fiber densification, the new radio, which is the remote radio heads that we today see on the 4G towers. Now they basically transform into these small cells that can go on poles, on building tops, uh, and a lot of utility meters and so on and so forth. So it's a lot more ubiquitously available, and it really aids all these new use cases that need ultra fast streaming, ultra low latency applications like driverless cars and drone support, and remote robotic surgeries, etc. Massive IoT scale, including the industrial IoT, which requires machine to machine communication robotics, which really ushers in the fourth industrial revolution, which is absolutely not possible without 5G. That's exactly what 5G is going to kick off, and that's why it's a point of inflection. And the immersive AR VR experiences, when you when you have the AR VR set, you actually are literally doing scuba diving. You don't have to train, somewhere else for scuba diving. You can actually wear that and experience that in an immersive way with near real-time speeds. And that's basically the promise of 5G. So, moving on, just a little technical aspects. I won't delve too much into it because I want to get into the exciting use cases. But we have to understand, we've heard a lot of hype about 5G globally, and our company was the global leader. But like I said, I'm not getting into the deployment aspects of what we have done in this session. But it's important to understand the real 5G versus a lot of hype that is out there. And 5G is really offered in three bands, as you can see, three frequency bands. At the top, you have the low frequency, which are, an example of 700 megahertz. These are low frequency cells. And you have high frequency cells, which are, you can see 3.4 to 3.8 as an example here. And then that's the mid band, as they call it. And then the millimeter wave, which is the high band, right? And this is millimeter wave is really what, because of the broader band, there's more bandwidth available at that higher frequency range. It is really giving us the speed that we need. Okay, so today on our phones, and I have an iPhone myself, and if you're lucky, you see speeds of 5 megahertz, 5 mbps, or maybe up to 19, depending on the cellular network you're on, maybe 20 if you're lucky. But average is around 7 to 10. And imagine going from 7 or 10 Mbps to 10 gigabits per second. That's 1,000 times leap of faith from 4G to 5G. And that's really the promise of 5G in terms of speed. And it's no longer just your last mile phones and tabs that will use it. There'll be a lot of enterprises that will get excited about this for the last mile because it doesn't require digging. If all the fiber is already in the ground and you have your new radios nearby, boom, you have the infrastructure in place to support services on the fly without requiring a lot of construction and disrupting daily life. So moving on, at the bottom, I kind of put a quick table together. And again, I want to remind everybody that the use cases of 5G are still evolving because technology and the capabilities and the opportunities that it literally unleashes are infinite, if I may say so. And that's the reason I've listed it from a very broad ranges here. Low band typically under a gig, and you get a bandwidth max. Again, physics basically says the max you can get is 100 Mbps, and it's available, when you don't have too many devices and all those other factors. And what we get there is best coverage and penetration. Why? Because lower speeds can go farther. So you have more penetration, wider coverage. That's why one cell can support, a 10 square kilometer radius or even beyond, depending on larger cellular sites or towers. Mid-band, typically, 1.7 to 6, and this may change as technology improves, can give you up to 1 gig, right? And this is the mid-band, which basically gives you faster coverage, and it starts giving you the promise of low latency. And not really low latency to the extent that we want to see in 5G, which is literally 1 millisecond, 2 milliseconds, which is mind-boggling. It's like your flipper, your blink, one blink or the flap of your eyelid is roughly about 25 milliseconds, 25 to 30. And just so you can imagine, it's 25 times faster than that is what 5G can bring. 10 gigabits per second speed. High band is 26 gigahertz and above. I'm not going to get into the specific bands that each carrier across the globe has commercialized or trying to commercialize this. You get very high bandwidth, very low latency, but subpar building penetration. That's why you need repeaters, you need small cells, you need fiber densification, and small because of lower coverage area. But the higher bandwidth, low latency that we get is practically impossible with any other technology before. And there's a few use cases that are listed in the picture here of smart cities, large events like stadiums and gaming, racing, the automated highways, driverless cars, and environmental sustenance, and so on and so forth, and smart cities and smart homes, etc. So moving on. So what are the possibilities? What are the speeds? So very quickly, this is again the history lesson of what the physics. Again, as you can see, physics basically gives you a theoretical maximum. It's not, and if you're lucky, you see that in a lab. You don't see that in reality because of many other factors, as all of us can understand. So 1G with 2.4 kilobits per second to 2G, 64 to 2 Mbps to 1 gig to 20 gig and beyond potentially, right? That's the promise of 5G here. And what it literally means is if you're downloading a favorite Star Wars movie, The Force Awakens, it would have taken 4 months and 27 days in 1G. With 4G now, about 30 seconds. And this is, remember, theoretically the fastest maximum speed available, which is very hard to get 1 gig speeds today, unless everybody shuts off their phones in that area and, in the most ideal situations. So it's a lot more than 30 seconds, to be honest with you, today. And we have the promise of downloading it theoretically at 1.5 seconds to, in reality, about 5 to 8 seconds. It's just mind-boggling, a whole movie. right? And that's basically the speeds we're talking about. And movies for entertainment, but there are many, many, many more industries, especially the medical, safety and security, and fraud detection, environment sustenance, global climate aspects. There are many more aspects where they are measuring Antarctica, for example, and other areas where we want to transmit the data faster, as fast as we can. And there are many, many such use cases that require speed and throughput and the bandwidth and the low latency needs as we move on. So at the bottom, there's a few examples of industries that will gain from this: high speed, high bandwidth, and a lot of people ask me, I get confused between bandwidth and speed. What does it mean? I basically tell them, think of it as a vehicle that's carrying, let's say you're carrying 100 apples from your home to another place. I'm just 100 carts of apple in your truck. You have your favorite pickup truck. You put 100 carts in your pickup truck and you're driving it. So you have a certain speed that you can drive, and you have a certain volume of apples that you can carry, right? So as we move from each generation to the next, we are almost multiplying 10 times or even more, as you can see, in terms of the speed and the throughput. So your truck now can go 10 times faster, in some cases even 100 times faster, and carrying 10 to 100 times, arguably, uh, more volume of data, which we call bandwidth or throughput. And it can do it at literally the blink, less than a blink of an eye, right? That's basically the promise of 5G. And it basically um, helps you with telemedicine, which is remote robotic surgeries in remote areas, remote villages, rural areas where you don't have as many medical facilities, and remote work locations like the oil rigs and many other locations where people have to work in areas where technology is not today very ubiquitous, right? And autonomous vehicles, which are becoming a reality with Teslas of the world, Ubers of the world that are trying this out, Amazons of the world, and UPS that are trying out drones for delivery, Internet of Things, all the wearables and the meters and the industrial IoT, the irrigation systems in the farmland supporting our agriculture. IoT is huge, and autonomous drones that I just covered, industrial automation, as we call it, Industry 4.0. And I have a slide covering that a little later. And the virtual and augmented reality, basically giving you the immersive experiences with that high bandwidth. So imagine you connecting via Wi-Fi and it continues to buffer because you're getting 4K video at the speed of light, the closest to the speed of light. And today, our networks don't support it. So we see buffering. And that goes away because the device you're wearing connects directly to the small cell, not to the Wi-Fi. That's the promise of 5G. So the 5G use case scenarios, and this is basically, ITU basically published this a few years ago. There are three major capabilities. In fact, there's more than three, but three major capabilities that 5G really unleashes. One is enhanced broadband that we were talking about, the high speeds and bandwidths, right? 10 gigabits, upload speeds and download speeds of 20 gigabits per second. And that's massive amount of video streaming and so on and so forth. And work and play in the cloud and some of the augmented reality use cases like AR, VR that we talked about. All these are possible with it. Now, massive machine type communications and M2M or M2X, as it's called, machine to machine to individuals, machine to infrastructure. All these communications are really possible up to 1 million within a square kilometer. And it really unleashes the power of a smart city, thanks to the availability of technology to support multiple devices in a small footprint in urban areas, etc. And between these two, you have smart homes or buildings like research parks or tech parks or these commercial, high-rise spaces where there's high requirement for bandwidth, as well as a lot of devices connecting at the same time. So you have a combination of both in this area. And last And absolutely the most exciting one is the ultra reliable. The reliability is key. Quality of service and reliability. If you promise it, you absolutely need to be able to deliver it. And 5G is the only technology that's capable of delivering that ultra reliable, low latency communication. For remote robotic surgery, where the doctor is here wearing those sets, is performing surgery, and a robot is actually doing it physically at the location. That's mind boggling. It will be made possible in areas that unfortunately don't have access to medical facilities today across the globe. And self driving cars, automated highways, and mission critical applications like health based, safety based, security based, highway safety, public safety, and all these are very critical. All these CCTV cameras all over the place, they capture massive amounts of bandwidths. I mean, they require massive amounts of bandwidths to support the data that they actually can stream instead of, you know, record and send in packets, and it only gets analyzed after the fact. That is too late because the fraud and the crime has already happened, and you want to do real-time analytics. So the ecosystem of 4G and 5G will continue to coexist for the next few years for obvious reasons. There in the urban areas, you'll see a lot more densification and a lot more devices that need to be supported. So you'll see a massive amount of deployment of 5G in urban areas, but in rural areas, not as much because there's not as much requirement there in terms of low latency and high throughput and whatnot. Industrial IoT and agricultural IoT does not require high throughputs and so on. Wherever it's required, you'll see those kind of deployments. So you'll see a lot more small cells, as you can see, connected through fiber, supporting all these last mile devices. And you'll have the 4G mobile base station. And remember, this is just the last mile wireless connection, which is the microwave range of non-ionizing radiation from a spectrum perspective that that wireless uses. However, when you switch to the anything beyond that point, once your cell phone captures the information, you have physical routers that are actually transmitting the traffic across the board. And I just want to highlight the hype cycle of, typically Gartner basically said 5G was at the peak of the last year of the hype cycle, and roughly it's in the trough. We are trying to realize now the potential of it by unleashing the use cases. And private 5G is really, getting up the hype cycle right now. I just want to kind of highlight where Gartner's research is. And very quickly, from a emerging technologies perspective that are evolving in parallel, 5G is the only technology that can really stitch all these technologies to give those massive, immersive user experience and drive the use cases in public safety and all the industries and usher in the fourth industrial revolution and beyond like never before. So what are some of the emerging technologies? Machine learning, artificial intelligence, augmented and virtual reality and mixed reality, which is a combination, and unmanned autonomous vehicles, whether it's drones, driverless cars, unmanned submarines, etc., to monitor marine life, for example. IoT that we talked about, which has massive amounts of use cases, and SDN NFV, which is a technology term for software-defined networking, network function virtualization, where your routers now become pieces of software that can be deployed in data centers, where compute and storage and network have become commodities today with hyper-converged infrastructure. That's something that I wanted to add, but the list was getting too big. So HCI is another emerging technology that will really, in combination with SDN and NFV, where we can software define, and in the past, to be able to support massive bursts of traffic, we would have had to have infrastructure to take your last mile wireless traffic across the transport, access and transport networks and core networks, as we call them in the network world. But in the future, or in the present, I would say we have technologies that are evolving where we can get high-speed compute and storage and network as commodities which are software defined. So when you have peaks that need to be supported, you can subscribe and you can provision on the fly with zero touch provisioning using scale out and scale up models. And that's the promise that today's emerging technologies bring. And when you complement them with the 5G capabilities of low latency, because that's possible with the new radio devices and small cells, and many other technologies that support it, and the virtualized RAN, which is basically your radio access network and the edge network. So the concept of open edge and the ORAN, which is the open RAN, is also evolving, where it also brings in, for example, if you have certain vendors deployed in the access network or in the radio in the RAN network, the compatibility, there's a lot of, cross collaboration that we had to do between different vendor equipment to make sure the interoperability actually works. That was a challenge before. With software defined, the vendor lock-in goes away and really unleashes the whole concept of high scalability and elasticity for the core as well as the RAN, the transport networks, as this technology evolves from an SDN NFV and the HCI spaces. And supporting massive devices using massive input, massive output, massive MIMO, or MIMO as it's called, and beamforming, which is basically where you have, you can point your beams specific to highways where there's a lot of traffic, or certain buildings which have higher bandwidth requirements, and so on and so forth. Of course, edge compute, which is the latest buzzword, MEC, MEC is the buzzword that the industry uses. Used to be called mobile edge compute because that was what it was. But now it's not just mobile, it's multi-access edge compute. It could be mobile, it could be wireline or wireless. The idea is to have computing done at the edge of where you're collecting data. So instead of collecting data one place, sending it to your central server in Chicago or wherever in New York City, there's a lot of latency, 230 milliseconds, send the data over. And if you have too many packets, it slows down. And then once you load all the data, you have to analyze the data after the fact in your reporting service in your data lakes, which is too late and too slow to detect some of the low latency use cases like fraud and security aspects and healthcare needs and public safety and whatnot. So in those cases, we want to move analytics to the edge, computing to the edge. And that's the whole notion of edge computing. And network slicing is the last thing. I wanted to include more slides, but in the interest of time, I just want to kind of get people excited about all these technologies and capabilities are coming to life. From network slicing, I just want to mention one thing. This slicing is across your RAN, which is your radio access, which is the wireless part, and the core and transport, which is the wired part. The slicing literally means we'd be able to dedicate slices, which are these virtual slices of the network that you can't see. But we can say this slice supports public safety domain. That means, near real time, near zero latency, you give, higher priority and preference to those packets over other packets. So you can define the slices, you can define the policies for those slices to support different use cases. To the other end of the spectrum, where you have electric meters and then in each house that send out their little pulses, once or twice a month with their readings. That does not require near zero latency. So that'll go on a different slice. So that's the whole idea of how you can slice and dice the network to support all these unique capabilities. And I just want to quickly highlight as well, a car typically traveling at 60 miles per hour, if you hit brakes, 60 miles per hour is like 30 meters per second. That's literally 0.3 meters per millisecond. And if today, when somebody hits the brake, that's roughly 10 meters of distance. If you have 300 millisecond delay or latency, this is the blink of an eye. And the bottom line is, you see somebody, a kid, and you hit the brakes, the time between the time you saw it and the system, the whole processing and you hitting the brakes is literally life and death because that's 10 meters of movement. And that's because of the latency challenges. But when you go to one millisecond, it's going to change significantly because you're able to stop within few feet, not even meters. And that's an example. And the fourth industrial revolution, the first one was mechanization, the second was mass production with electricity, the first driven by the steam engine, second by electricity, and the third by digitalization, the information age that started with computers and automation. And now with the fourth and fifth industrial revolution, where you have cyber physical systems, where you have cognitive as well as machine to machine communications that is going to be powered by 5G, and the fifth and beyond that really can have chips in your brain that can order things and whatnot. So this is the future that people are dreaming the dream. Okay. And last but not least, all these services, seamless connectivity, bandwidth, uninterrupted videos, immersive entertainment, zero lags, video calls, driverless cars, zero latency gaming with immersive experiences, IoT growth, and remote robotic surgeries for telemedicine, industrial IoT, and automated highways. These are the promises of 5G. And some of the industries that benefit the most: manufacturing with smart factories, transportation with driverless cars, V2I or V2X as it's called, vehicle to vehicle, vehicle to infrastructure. Telematics fleet management becomes simpler. Next gen infotainment, where you can literally send out localized ads to local areas where people are driving. Smart cities with smart traffic management, public safety, and so on. Smart home with in-home media immersive experiences. Connected healthcare with telemedicine, faster image transmissions, etc. And retail with AR, VR-based products, immersive gaming, mobile broadband, etc. And agriculture with all the IoT, irrigation, fertigation, effective crop management, etc. Last thing I want to mention are a few challenges: the high cost of deployment, high capex with fiber densification, the new radio that needs to get deployed, all the virtualization of the RAN and the core and the transport and the edge that will need to support the scale and the elasticity, security and privacy of these millions of devices that are going to connect, and the control plane, which needs to have a lot more security, because now with the central control, you can really affect the destiny of a lot of DDoS threats on the vRAN as well as the last mile devices. Deployment coverage is narrower because of the higher speeds. Spectrum availability is much higher at the higher bandwidths, and it needs to be made available. That's what I meant to say. And that's where the governments are working in different across the globe to basically expand those. And that's when you hear the auctions that happen. And of course, the global regulation standards, so the whole world can speak the same language. And they say 5G should not mean different things in different countries for different vendors and different service providers, and the interoperability. So what next? 6G. What does it bring? Sky's the limit. And I just borrowed this from the millimeter wave networking group in Europe. I believe it's in Italy. And I just borrowed this, a few ideas there: high energy efficiencies, disaggregation, cell-less networks, basically ubiquitous connectivity at highest speeds you can imagine, that also help with high energy efficiencies, and that has to uplift mankind. So with that said, I take a pause here and see if there's any questions.
Well, thank you very much for that, Praveen. Greatly appreciated. And yes, we do have some questions. First and foremost, it's great to just see somebody speak so passionately about something. Really amazing. So yeah, I really appreciate you taking the time to do that and provide those insights for the attendees. So we do have a few questions here. The first one does come from an anonymous attendee, who just asked, when do you think we can stop running Cat6 or CAT6 cable in our buildings and use 5G Wi-Fi internal networks instead of our buildings?
Absolutely, and that's the promise of private 5G that's evolving, because there are two types of use cases today for connectivity. You have private connect networks. That's an intranet that allows you to connect to your healthcare systems or timesheets, your internal applications, which are not in the public domain. And then you have the public, right, cloud, which is available through internet. So for both of these, 5G is going to, bring the possibility of 1 gig, which is already tested by a lot of commercial companies. Like I said, I don't want to get into a Verizon conversation here, as I mentioned earlier. But the promise of 1 gigabit Ethernet and 2 gig is already out there. You can Google and find all the use cases that are evolving up to 10 gig. And that's what is going to unleash the capability of you having wireless last mile access, which will replace the need for your Ethernet cables, the CAT cables that you're talking about. Absolutely, that's the promise.
Fantastic, thank you. Tanwir from Wells Fargo asks, while driving cloud transformation journey towards the edge computing, what's your opinion on cloud adoption leveraging these 5G edge providers like Verizon, for example, to accelerate?
No, absolutely. That is the promise of the future. So there are many companies that are very excited, many enterprises, small, medium, large, that are very excited in terms of what 5G is unleashing. And they are partnering with a lot of these service providers to actually build those use cases, because sky is the limit. Like I said, with 5G, we haven't even imagined where 5G will take us in 10 years. People are still imagining the dream, right? Because the emergence of all these emerging technologies, or rather the convergence of the emerging technologies with 5G is just mind-boggling. And the use cases are just mighty too many to discuss on this limited time. Absolutely.
Fantastic. Another question here is a bit of a double barrel question, but it's how will organizational wireless deployments be impacted by 5G? So how will organizational wireless deployments be impacted by 5G? And will organizations continue to upgrade standard wireless access points on their campuses? Or do you envision 5G technology replacing standard access points and access to internal networks?
Yeah, I would say all of the above, because in some cases, we will absolutely see some of those replacements that you're talking about. And in other cases, we can absolutely have scenarios where there'll be a combination of both. There'll be a combination of both, especially where you're in an underground vault with high security, whatever. It could be the mint where they store the gold. It could be, high security solutions, the federal sector. I don't want to get into too much detail. In some cases, you may not have 5G penetration there. So it'll be a combination of both. So it's very hard to give a single answer to the question, but based on the use case, the promise is if 5G can get there, boom, yes, absolutely. It has the potential to replace the wired connections. But like I showed earlier, for the near future, there'll be a combination of both that really unleash the power. Because don't get me wrong, 4G transport and core is very, very powerful. When we actually virtualize the edge and the core, sky is the limit, because that's exactly what 5G needs. It supports the 4G networks as well. Hope that answers the question.
Yeah, and then a final follow-up question here from Tanwir, just asking, will the market for 5G backhaul services be the same as it is for 4G?
I think the market is going to significantly change. People, just like the pandemic has changed the way we are living right now, 5G is going to change the way now that you can transmit incredible amount of data at incredible amounts of speed and with ultra low latency. That really brings a lot of use cases to the fore that 4G is not able to provide today, right? And wired connections have the promise of providing those ultra high speeds and the bandwidths, but they come at a cost of deployment. They come at a speed of deployment is much slower. To basically get the regulatory approvals to take the last mile to a building, it could take months. That's how difficult it is. Whereas with the fiber densification that we're seeing with all these large uh, communication service providers across the globe, the connectivity is there. You just have to provision zero touch, boom, you get a device, and then all you have to do is power on the device that will automatically connect to the small cell, load the operating system, load the hypervisor, load the virtual components, and boom, it runs. It can run your virtual firewalls, virtual. So the SD-WAN, which is physical today, there's a promise of that going virtual as well, some components of it. So, people are dreaming this dream, and SD-WAN is real. When SD-WAN evolved, software-defined WAN, people were very skeptical about it. They're like, nah, it's not going to work. But it is a reality today. It helped us move away from the expensive MPLS technology before, uh, and now move into a much more agile, much more scalable model of the SD-WAN, software-defined. Anything software-defined gives you scalability, agility, and reliability that businesses need for today and tomorrow.
Fantastic stuff. Well, thank you very much, Praveen. And everyone can just join me in a bit of a virtual round of applause for Praveen for his time and very passionate insight into the world of